Hi guys, so today we are solving the second problem from the grind 71 list. So this problem is valid parenthesis. Let's take a look at it in our whiteboard. So we are basically given a string as containing just the characters. Okay, the bracket, so S will be containing either this or this, 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 curly, and this one, and we have to determine if the string is valid. So valid string example can be this or this, or even this is a valid string but this is invalid as the curly one does not have any closing bracket. Right, so how to approach this? So we just need to return true or false, right? So in input we are having a string s, output should be bool true or false. So how can you approach this? What I am thinking is, like, if we can iterate over the string. So for example, the string is this, right? And we loop over it. So like first we are here, and then we check in check the uh, element in front of it. So let's say this is I and this is j, and we this keeps on moving step by step. So if I is here, we will check in this whole array, like if the complement of this exists. So what I mean by that is, so let's take it brute force approach. So one way of doing this is we can iterate over this whole string. So for int I equals 0 to n minus 1, where n is the size of the string, and then we can take another loop for j equals to, starting from j equals to I plus 1 and goes up to n minus 1 as well. So we'll basically check if the next element is equal to the complement of this. So by complement, what I mean is, if uh if I was this, so j and j is this, then this is true, otherwise it's not, right? So this is a brute force way of doing it, but this will be uh order of n square. Now since we can make an observation over here, like this is a nested loop, and whenever there is a nested loop with the inner loop starting from outer, like in this case it goes from I to n, but j goes from I to n, right? This I starts from 0 and this j is starting from I. So whenever this kind of problems arise, we should always think of stacks, right? So this is the one major observation in this problem. So let's see how we can optimize this order of n square to order of n using stacks. So let's take it to a new page. Right, so how can we include stack in this? So we can see here, like, the inner loop, we are checking for the opposite ones, and comparing it with the inner. So if we can somehow push the elements in the stack and compare it, then I think it will do the trick. So let's make a temporary stack over here. Like, so let's call this this will be a stack of character st, right? And we will push it in the stack whenever we find opening braces which on the left hand side. So what I mean by that is, if the if while so the outer loop remains same for I equal to 0 to n minus 1, if your array of I equal to this or this or this, so we will push this into the stack, right? And if it is not, then we will basically call a function to which will check for the correct set of parentheses. So let's talk about that function in the next slide. So this will be check stack, right? So this will give us a boolean result. So if the element is present in stack, if the right curly braces is present in stack, then this will continue, right? If it is not, then we can just return false. Right, so let's dry run it for our check stack function in the next slide. So our let's say our input was input s was uh let's take it like this, right? And so in this stack, using this equation, like this part, so we will use this, right? So whenever we encounter a left hand brace, we will push it into the stack. So this is our stack, we encounter left brace, we push it, right? And then again we push got a left one, we will push it, then we got a right one, so we will go into this else condition in our check stack function. Now in our check stack function, what we can do is we can basically check if, so I will be having the function definition as this check stack. I will be getting a character and the stack itself. So this is st. So I will basically check if my character that I have received is a left one, and in st.top I have the opposite, sorry, this will go in the else whenever there is a right brace, right? So this will not be this, but actually this will be if ch equal to right hand side brace and st or top is left hand brace, then return true, else return false. So this will be similar for, like, this will be a nested, not nested, but else if condition. So that will check for this and this. Okay. Also, a very important thing to note here is, so what if your stack was empty? So like if there was no elements, then what that means is your input must have been this, and this is definitely an invalid. So we first, even before doing this check, so do this one. If st.empty, then also return false, right? And this is very important because uh, if you didn't check this condition and you are trying to pop something out of an empty step, you will get a segmentation fault. So please keep a note of that. Right. So I guess the yeah, one more thing. So when you have checked it, and so this is before returning true, just do a small st.pop. So it makes space for other one, and similarly for next time as well. So let's continue our dry run first of all. So we done with this, then now we are here. So it's right, uh we checked for this actually. Now we have come to here. Now again it's a right brace and we checked in the stack, so the corresponding complement is present, so we pop it and return true. Now there's a left brace, we insert it and then we move to the next. So it's a right brace and we check in the stack. It's yeah, it's the complement, so we pop it. So now in the end, right, with after this loop ends, if our stack is empty, then only return true, else return false. So why is this, right? So to answer this, like let's take this case. So s will be this and this, right? Now our stack will be populated, like, because all of these are left braces and no right braces, it will just populate with this and the loop will end. Now this is not correct obviously, right? There is no curly braces, therefore we will do a sanitary check in the end after the loop. If the st dot empty, if st is not empty, then return false, else return true. Okay, so and yeah, so this way you have decreased the time complexity to order of n, and the space complexity is order of n as well, because you are using stack of max size n. Cool. So now let's jump to the code. Okay, so this is the coding part of our video. So if you have been following this far, then you must be able to understand it pretty goodly. It looks lengthy, but it's quite simple. So let's walk through the code. So we have to return a bool, right? And then we have just declared a stack and pre-computed the size n. So we are iterating the loop over the string. So string is this, let's suppose, right? So if the it's the same like the dry run is only. So if we are encounter our left hand side curly brace, then we will push it into the stack. Otherwise we will check for its validity, like if the it's valid or not. So it will only come when right side brace is there. So this check validity is this one, this our helper function. So we are taking a character which is always a this or this brace, right? And our we are passing the stack as the uh, pass by reference. So inside this, the very important condition is to check if it is empty or not. If it's empty, then just return a false, because then you cannot do any pop operation. And if it's empty and you ever encounter a right hand brace, then it definitely means like uh, your equation was something like this in the string. So okay, so what if it's not? Then will we check for the corresponding complement inside the stack itself. So either this, then we will, if this is true, then we will pop it from the stack and return true. Now if it's returning true, then we will continue, right? Because this is just for one instance. So inside the stack it may be this, this, or this. So even if it's valid for this, then also we need to check for the other ones, right? So unless the whole stack is not empty or something like that, we can't exit the loop yet. But if it returns false, like if it's empty, then it's definitely false. Then that is why we are returning the false here. Now after this loop is completed, we will be exiting this part. And still, if there is some element remains inside the stack, then it's a problem. Like that means the pop or the corresponding right hand brace was not found. Then we can return false, otherwise we will return true. So yeah, that's it for this video. So the key takeaways from it is, like, we are using a stack. Okay, so the key point here is, like, we are iterating over the whole string, and we are inserting into the stack whenever we are receiving an left hand side brace, right? And whenever we encounter a right hand brace, so we check if the corresponding left is present, uh, in the stack dot top, right? So, and make sure you are not accessing the an empty stack, otherwise you will get a segmentation fault. Next is to, now if you have returned a true, like you with your from your helper function, so make sure to keep checking for all other rights. Like don't stop unless you're not iterated over the whole string, right? But if it's a false, then you can just definitely break the loop and return it. Now after the loop ends, if the stack is empty, then it's great. But if it's not empty, then you should return false. So yeah, that's it for this video. Thumbs if you liked it, subs if you loved it. Thanks. See you in the next one.